My name is Christy Hansen, and today I'm going to talk to you about how STEM has been important in my life and how it's gotten me to be where I am today. And I think one of the important messages from the previous speaker and what I want to tell all of you in the audience is, I'm sure you're middle school and high school and you're wondering how you need to be the best, you have to have the best grades, it's super competitive. And one of the messages I'm going to talk to you about today is it isn't always about having all A's, it's about who you are as a person and what do you enjoy. And part of the reason why I was able to do all the things I did today is because I just had a great attitude and I never gave up. And a message here is, you might get a B, you get a C, or you have someone maybe growing up telling you can't do things. Like back in my generation, there were still some kind of doubts given on women who wanted to take advanced physics courses. And the message there is that I never listened to anyone. Like I never ever thought that I couldn't do it. And I remember thinking, well, just because you can't do it doesn't mean I can't do it, right? So that's one of the messages I want you to take home. What do you love to do? What do you love to study? And you can create your own field. So just keep your mind open and follow what you love. So my title today is on being a force of nature, because one of my bosses actually once called me a force of nature, somebody who gets things done, right? And if you become someone who is responsible and who gets things done, you're going to get the great projects and the great assignments. And I think that's what helped me advance my career to where I am now. And I'm going to give you a little bit of a background so you can understand. You have questions, what kind of classes should you take, or what did I do? Well, how did I get to where I am? What did I love? So when I was your age and even younger, I always wanted to be an astronaut. That was it. It was that and a stunt girl, because I used to watch Wonder Woman shows, and I wanted to be that stunt girl kicking everyone's butt. So those are the two things I wanted to be. But eventually it was an astronaut. Space, I love space. Read as many books as I could on it, but I didn't know how I was going to get to work in the space environment, because when you're younger, you think, it's just astronauts, but there are so many other things you can do out there, and that's what I'm going to talk to you about today. Space, I love science. I used to play with Legos. You guys have more impressive Legos these days. Engineering, building things, how do things work? I liked adventure and sports, and I just did what I wanted to do to enjoy my life, because if you follow what you enjoy, you're going to do better at it, and when you run into hurdles, you're going to keep going, right? And nothing fires me up even today than when someone tells me, I don't think that's possible. And as soon as I hear that, there's this fire that ignites inside me, and I just can't wait to show them that they're wrong. So that's kind of what helped me get to where I am. And each of you will kind of have your own drivers that do that. So in high school, I was a student athlete. I loved sports, played volleyball, track and field. I threw the javelin, but I loved science. So I took advanced physics courses, and I did physics Olympics. And today, you guys have so many more opportunities. Like, look at this X-STEM event. We had a couple of things in school, but I tried to be involved in that. In college, kind of the same thing. Like, it was hard for me to pick any individual science. I liked them all. So I studied, it was called comprehensive science. So it covered chemistry, biology, physics, and all the calculus and math courses. But then I minored in physics, because that's what I was mostly interested in. And I played volleyball, right? So one of the messages I say is you study in school, but what else do you do? Because that builds your character, right? So volleyball, sports, and teamwork, and that kind of will make you an asset when you're looking for a job. Can you work well with others? Because not everybody can. Moving on, so I went to graduate school, University of North Dakota. Who knows where that is? I didn't even know. They had a master's in space studies program. You could study anything from remote sensing, life in the universe, orbital mechanics, the Russian space program. I didn't even know where I was going with that degree, but I'm like, I'm doing it. And I went to Grand Forks, North Dakota for 2 years. There were underground tunnels, and it was like minus 30 degrees. But I loved it. It was the first time I saw the Northern Lights. So coming out of grad school, I remember my mom being like, where are you going with a space studies degree? And they used to videotape the classes. And they'd send the classes to distance students. And distance students at NASA Johnson Space Center, people overseas would watch our videotapes from the classroom because they were taking the classes remotely. And some engineer at NASA saw me on the videotape participating, like I was energetic in class, and reached out to me and said, you know what? We're getting ready to build the International Space Station. Who's heard of the International Space Station? Do you guys know what that is? Right. It was 1998-99 timeframe. They needed to hire new, young, energetic engineers to work on building the International Space Station. And I was like, well, I don't even know what that means, but I want to do it. That's what I'm doing. So I sent them my resume, which I didn't have, but I made one. Flew down there, and they interviewed me, and I'll show you at the neutral buoyancy tank. You'll see a picture of that. And I don't even think I listened to what they were going to pay me or anything. I was staring at this water tank with mock-ups in it, and I was like, I just said yes. And before I knew it, I was in Houston, Texas. So that took me to Houston, Texas, where I'm going to talk to you briefly about what it means to be a spacewalk extra-vehicular activity engineer, an astronaut trainer, a flight controller, scuba diver, and working on space station Hubble shuttle projects. And now I'm actually at NASA Goddard Space Flight Center, which is pretty close to Washington, D.C., and I do something called airborne science, where we fly all over the planet on NASA airplanes collecting data, which is pretty cool too. Okay, STEM career path, just tying it all together, science, technology, engineering, and math. And it seems like you have all these individual quantities, but really you can combine and move it all around and find your love and create a space for you that you're gonna love and that you're gonna excel in. So engineering, kind of my first field. So I did some engineering and operations, and you can just see what astronaut training, flight control, working in weightless simulators, and we'll talk about the KC-135 Vomit Comet. Who's heard of that airplane? So I'll show you a little video of that. And then my more recent career has taken me into more project management, but I work with a giant scientific community and all the scientists and engineers, and I plan big missions that go to Antarctica or Greenland or Chile, putting instruments on airplanes, collecting data, all the logistics involved. Okay, so here we go. This is me. I'm in McMurdo. It's a runway made out of sea ice, 8 feet thick. Airplanes land on it, right? So in 2013, I managed a project to get all of our scientists, instrument teams down to McMurdo. So today, what I want to do is tell you, follow your dreams. I did, because I don't want to bore you today. I remember it was like being bored in auditoriums. Can you feel the fire? So someone gave me a challenge, and I'm like, I want to do it. No one believed we'd be able to get a NASA airplane down to McMurdo, and I was like, I want to lead that project, and they gave it to me, and it was hard, but we did it. Nothing can stop you, right? So if you, deep down inside, you know you can do it, you just keep pressing. Drive, passion, and persistence. I believe to this day that is how I got to be where I am. Like, you want to be a good student, you want to be responsible, but you just have to have that self-drive to go, and never give up. So with that, this way to awesome, I'm going to talk to you about developing your own awesome career. First part of my career, extra-vehicular activity. What does that even mean? It means you're outside of the vehicle. So maybe the astronauts on the space station are inside. When you want to go outside in the vacuum of space, it's super hot, super cold, there's no air. You have to wear a spacesuit, right? So could you imagine you're trying to build a structure? It's like a construction job, right? But then you build it in this big spacesuit. It's very hard to move around. You don't have a lot of dexterity. You don't have good, you can't do this in the spacesuit. You can't do this in the spacesuit. You're kind of like stuck like this. So I had to learn, how do you teach astronauts to work in a spacesuit where you have limited mobility and limited dexterity? How do you work in microgravity? How do you build a space station? So I had a general skill set in school, right? I did well in school, and then the idea would be I'm capable of being taught. So for 2 years, I was a trainee until I learned everything and I passed my certifications, and then I was assigned to work a space shuttle mission or a Hubble mission. So EVA, okay, you're outside, you're working with tools, you can see that, space station or shuttle. There's hazards you have to deal with, right? Like the crew, we need to make sure they don't float away, right? So you have to be tethered. Could you imagine, like if you let go of a tool, on Earth, what happens to a tool if you let go of it here? Right, it drops down. What happens if you let go of it in space, in microgravity? Right, it's gone, right? So if you let go of it and you don't impart any forces on it, it might still be floating there, but if you let go of it and your hand bumps it, it's gone. It's going 17,000 miles an hour away from you. It could come back around and hit you or hit the vehicle. So those are all kinds of the factors that you have to learn. This is where I was interviewed for my job. Could you even believe it? The neutral buoyancy tank, okay? So it's 202 feet wide, 101 feet long, 40 feet deep, 6.2 million gallons of water. So this is where we mostly train astronauts to do the extravehicular activity. They fill the pool, they fill it all the way to the top with water, and they put full-size mock-ups of the space shuttle or the International Space Station. So, the real ones are in space, right? But then they can build these mock-ups out of special plastic. They go underwater. We can put astronauts in spacesuits, take them underwater, and it, for the most part, mimics most of microgravity, not everything. I mean, when you go underwater, you have water drag, right? So you have that resistance. So when you're moving stuff, it's a little bit harder. In space, you're not going to have that resistance. So we have to understand those differences. This is all part of STEM, right? Application. So you take your science courses and you're like, why do I need this? How is physics? You're taking physics. I used to think, how does this relate to me? And then you get these applications. Suddenly you have to understand what's happening in zero gravity or what drag is, but it's pretty cool, right? So I would go down underwater sometimes on scuba and teach the astronauts, these are the tools you have to carry. This is how you get from point A to point B. They have to use their hands and they have to go really slow because they're in these bulky gloves, and if you squeeze too hard, your hands get, so it's a lot of ergonomics and physical training. You don't want to fatigue your hands, so you have to go really slow. So you teach all of that underwater. This is me, remember my flex shot? I like to do that at least once everywhere I go for the first time. And you can imagine, imagine this, I like to talk, I'm a talker, I can talk a lot. Then I have to teach astronauts underwater where you can't talk. At the time, we didn't have the underwater masks, And I was like, how am I going to do this, right? So you can write procedures down on underwater paper in a clipboard with a wax pencil. So you practice it on the pool deck with the astronauts. You tell them, this is what we're going to do. I'm going to point to step 1. You're going to come down. You're going to follow me. We're going to go to step 1. Hook up electrical connectors. So I point, and then I point to the panel underwater. So it's really kind of slow, and it's frustrating anyway. So my first day, right, and you're like, I'm going to do a great job. I start diving down, right? I have my clipboard, and I think everything's fastened in the clipboard well. I'm going down, and they're following me, and the next thing I know, I look up, all of my papers they've released from the clipboard, and they're floating in the water column all above me up in the air. And like, what do you even do there? It's like, okay, adapt and overcome. I'm like, so I look at, I'm getting them, I'm like looking at them, and I have to go, right? So we go up and everyone's grabbing the pages as we go up to the top. So we made sure it was stapled correctly, and I had a stronger spring on the clipboard the next time. But then you never do that again, right? Okay, so donning a spacesuit, putting on a spacesuit. So why would I do that? Again, I would love to be an astronaut someday, and similar to the previous conversation, if I never become an astronaut, this is as close as you can get. So in order for me to train astronauts, right, they have to know a lot about everything. They have to know about mechanical systems, electrical systems, life support systems. So they can't know everything on spacewalks, but that's my job. I have to know everything on that one little area. So in order for me to understand what they're going through, I'd get to don the spacesuit. So if you look here, first of all, you have to wear a diaper. Okay, when was the last time you put a diaper on yourself? So that was interesting. So the first time I had to do that, and I couldn't get it to fit anyway. Then you put this long underwear on, right? And it has 300 feet of tubing woven through the long underwear that actually runs cooling through you when you're in the spacesuit, because you generate a lot of heat, and where's the heat going? So somebody thought through this, right? STEM topics. This cooling loop goes against your skin and pulls heat away from your body and scrubs it, right? So then you put the lower torso assembly on, so those legs, I'm sitting down there, and then you have to climb into the hard upper torso. So you're in like this squat thrust like this, and you can't see what you're doing. And if you're claustrophobic, that's not good, because you get stuck inside there and get yourself up. And when you're not used to it, like I was sweating at the end of the activity before we even started for the day. But then you do water runs yourself, so I can understand when I see a crew member flailing or moving slow, I can understand what they're going through and be a better instructor that way. So anyway, that was an amazing experience doing that. So in addition, part of my job would be, so our motto was plan, train, fly, right? Plan, train, fly. We plan the mission, okay? Christy, your task is install 5 huge batteries on the space station, retract the solar array. So I have to learn, what is that? I work with Boeing, they design the hardware, I write those procedures. I train the crew in the neutral buoyancy tank and also in virtual reality simulators. But then also, before the shuttle launches, we go out to the launch pad and we do EVA classes out on the launch pad. So this is just a fun picture. It shows me there's scaffolding all against the orbiter in the lower right-hand picture so that I can get close to the wing. And then I would actually teach classes outside of the space shuttle explaining, hey, if this mechanism failed, remember these are the overrides, because we previously only did it in a mock-up in the pool. And the mock-up in the pool is like plastic with holes in it, so it doesn't look flight-like. So we always need to make sure when we demonstrate the motor skills in the pool that they remember what the mechanism really looks like. So we'd get out to the pad and do that. So let's watch this, okay? Who's heard of the Vomit Comet? Vomit Comet, the KC-135, have you guys heard of it? So that's me spinning right there. So NASA has an airborne science program, which I'm working in now, which I had no idea back in the day that they had that. They have an aircraft called a KC-135, and it flies in something called a parabolic trajectory. Do you guys know what parabolas are? Do you know what they are? So you can see in the picture on the upper left there, so the plane flies up 45 degrees nose up for a while, and then it drops down, it's 45 nose down, and does these parabolas. So when it's coming up over the top, and as it drops down, you get about 20 seconds of free fall, so where you're really floating in the plane. And on these days, we had serious work to do. It was after return to flight after the Columbia accident. Our EVA group was brought into figuring out how to repair damaged tiles on the space shuttle. So we had to develop tools and techniques. So in microgravity, how's this tool going to work? We had to squirt this goo out. And how's goo going to squirt in a gun is it going to float when it comes out? Is it going to stick to stuff? So it was kind of a lot of hard work. But at the end of the day, you're like, oh, in the last couple of parabolas, let's spin around and do whatever we want. So the problem is you can start getting sick, right? And you don't want to be getting sick on the plane, because then they'll never fly you again. So I remember, so that's why I have these white bags all stuck in my flight suit, because if you throw up, right, could you imagine? If you throw up and you're floating, and then the plane goes down to what's called the 2G pullout. So when the plane starts to bottom out, you feel 2 times as heavy, so your body's heavy, and everything kind of smacks down to the ground. And I didn't want to be the one person who threw up and had puke splatter all over the side of the airplane. So I was as careful as I could, but after that little spinning session, I got that I was glad we were landing because I felt like it was coming. So you save that to the end of the work, right? Okay, here's just another picture. This is in the back of the KC-135. We're floating. That yellow line represents, it's something called a safety tether. It's 85 feet long. We have to keep the crew members tethered to the space station while they're there so they don't float away. And this was just, it happened to be a very, very long tether, and we didn't know how a large mass on the end of a long tether would behave. So we were demonstrating, we were all balled together trying to represent the mass of a spacesuit, which is like 300 pounds. So we all balled together and tried to figure out what the dynamics of that long wire were. So that was a little bit of work. In this example on the KC-135, we had to test the hardness of a material using a tool called a durometer with a little pin on it. So the astronaut, who's actually from Sweden, he's on the bottom of the plane, he's trying to rock this instrument, and then they wanted to see how the instrument performed with kind of the representative weight of a spacesuit on his back. So we're like, how do you represent 300 pounds? We just all grabbed onto his back and tried to simulate it. This is just a fun photo. Some of this goo stuff that we'd squirt out to represent repairing tiles could get stuck on your hair permanently like gum, so everybody had to wear bandanas and eye protection. Okay, so just taking you on a journey. So all that, you train, you practice. Now, STS-125, final space shuttle, final Hubble Space Telescope mission. Did anyone follow the Hubble missions at all? Do you guys know what Hubble is, right? So real quick, I'll take you through these slides. Hubble Space Telescope picture there. So what does it mean to service the telescope? So NASA created a program that allowed astronauts to go up to the Hubble Space Telescope and fix it or upgrade it every couple of years. You know, you have to upgrade your phones, your laptops if you upgrade it. Same thing, I mean, you would laugh if you saw some of the electronics on the Hubble Space Telescope. They were designed in like the 60s and 70s. So we have to go up and fix things, right? So on my mission, it was my job to explain to the astronauts how to change out the batteries, the gyroscopes, you know, and I had a large team, right? It wasn't just me. I was the lead EVA person, but a large team of people working together. Here's a sample on the ground, Goddard Space Flight Center. They actually have models or mock-ups of the Hubble Space Telescope, so you can teach the crew standing on the ground how to change out gyroscopes. And it's interesting because when you open the doors, they have gyroscopes that they move and point the telescope, right? Move it to point to stars, stabilize the telescope. They fail a lot, so you open what's called the aft shroud doors, and then these big three guys are like each 6'1". They have to get in here, and normally you'd be floating and remove this box and not touch anything around you. Could you imagine doing that? Not touch anything around you. You can't scratch the inside of the telescope or bump into like an optical star sensor, which is right above your head. So all of that is factored into training an EVA astronaut. This is in the water tank, so you can kind of see we have a robotic arm, crew's on the end of a robotic arm, pulling out an instrument, right? So this, you can see it looks like a little cheap looking because it's mock-up material, but we're demonstrating pulling out something called a radial instrument, like a pie piece. Untorque the bolt, you slide the instrument out, put it away, get a new instrument and put it in. And here, you know, could you imagine the astronaut, he has this bubble face, he has a giant piece of pie in front of him and he can't see anything. So he has to slide this instrument into the telescope and without damaging the guide rails that it slides on. So he has to use his other astronaut, the buddy in the back, who's what we call GCAing, watching him, telling him clearances like, okay, translate it 4 inches to the left. So the guy on the arm's doing this. Okay, I need you to pitch the mirror up 4 degrees. So he's going like this. So they have to use continuous communications to make sure they don't damage the hardware. This is just me back in the day. I was a flight controller. Failure is not an option, right? You guys know, Apollo 13? Who's seen Apollo 13? So we don't really say that anymore in there, but you're trained, it is not an option, right? So you train and you write, I probably wrote 200 contingency procedures before we launched, just in case something went wrong. So that if something went wrong, you could execute them right away. You don't have time to develop them on the fly because the spacewalks are only 6.5 hours each because that's as much oxygen as you have to breathe. This is just a pretty picture on orbit. That rectangular box, that's an instrument that we pulled out. And the first spacewalk, the bolt would not unlock. The very first one. This was the #1 priority instrument, and the bolt would not unlock. So we had to run through all these procedures that we had worked ahead of time, like, is it the torque limiter? Like, we have a ratchet. Are we limiting the torque too much? We pulled the torque limiter off. You know, you have a limiter on your ratchet so that you don't damage the telescope. Well, we had to take that off, and then our guy on the arm really had to crank down on that wrench, and he finally broke torque on the bolt. But there was a risk he could have broken the bolt shaft, so that had everyone on the edge of their seats. This is just an instrument of that same, picture of the same instrument going into its stowage container. And then here's just a fun picture in the payload bay. This is what the inside of the payload bay looks like. You have to wear something called bunny suits, right? Because you have these sensitive materials, mechanisms that move and close, like the payload bay doors. So here you're seeing the inside of the payload bay of the space shuttle. It's empty because we didn't have the cargo in it yet. And that red box at the top, that's holding the robotic arms, just protecting it. And I would teach classes in that as well. All right, leading on to the second part of my career, we're almost finished, airborne science. What a big change for me. I didn't even know NASA had airborne science airplanes. And when I was looking to try something new, and this is what I'm talking about, like follow your heart. I didn't want to do a boring desk job. Like after having done EVA, what else is out there? I did my own research. I looked at Goddard Space Flight Center, looked around, and I heard about this project called Operation IceBridge. And the only thing I needed to see was they fly airplanes in Greenland and Antarctica. And I was like, I want to do, like literally, I want to do that. I went to one of the big bosses at Goddard, said, here's my skill set. It's unmatched. I did this at Johnson. I can turn it into operations or management on your airborne science mission. And they hired me for the job. So we equipped different airplanes with science instruments like lasers, radar systems, radiometers, digital cameras, flying all over the planet, learning about the Earth, changes to the Earth like vegetation, water. I just happen to be studying ice on mine. So sit back, I'm going to show you something really cool. This is the view out of the cockpit of the NASA P-3 airplane. This is what our view out the window looks like, 1,500 feet flying over a glacier. So that's a glacier you're seeing there. We fire lasers and radars and measure the changes in that same ice every year and to see that the ice is changing. Now we're coming up to what's called a calving front. So this glacier, which is ice that also flows, breaks off at this angle. That's what that edge looks like. Doesn't it look like you could just reach out and like scrape the ground? The first time I thought, there's no way we were 1,500 feet. It felt much lower than that. I was very fortunate to have an opportunity to go to the South Pole. We didn't have work at the South Pole, but they were doing a science team transfer from McMurdo to the South Pole. And because this is part of the you're ready, you're prepared, I had given objectives to the McMurdo science teams on what I needed to accomplish well in advance. And one of them was to get our pilots some flight time on the airplane. And that we didn't have to land anywhere, but I want our pilots to have flight experience flying in Antarctica. So they said, Christy, you know what? You told us this ahead of time. We have a science aircraft going to the South Pole, and you guys can fly on that. So I had a chance. It was my 30 minutes at the South Pole. He's like, we're going to land, dump off the science team. He goes, you have 30 minutes to run to the pole, do your ceremonial dance, and get back on the airplane, and we're leaving you there. So, and when you land at the South Pole, it's high altitude, so it's on a glacier, right? And you're up high, so I don't know if you've heard of hypoxia, you know, there's less oxygen in the air. And we land, it's -20, and the whole thing I thought, I'm like, where is it? And I'm trying to run, and my heart was pounding, I was huffing and puffing, and I couldn't even talk to anyone. I'm like, just someone get a video of me going around so I can say I ran around the world in like 3 seconds, right at the bottom of the pole there. And then this is our ceremonial South Pole. So they have the geographic South Pole. So they put the geographic South Pole at the geographic South Pole location every year, but it's planted in ice. So how weird is this, right? So the ice moves every year, right? So every year, like so that moves. They have a ceremony. They pull the pole out of the ice. They find the geographic location. They plant it again, and they have a big ceremony every year. And then one last message. It's like, so the important thing is like you need to have fun too. Like I like to have fun. I like to go out and do things. I mean, I like to work hard, but I like to have fun, right? Because you want to be happy, and if you're happier, you're going to keep going. So things that I've done, I like to try all kinds of different things. I don't know about that claustrophobic scuba diving. That started making me sweat when I was watching that, but I like big open areas of water to scuba dive in. But I love to play sports, hiking and kayaking. So I've tried skydiving and bungee jumping in Costa Rica, and I like to sing in choir, travel. So anyway, the question to you is, what do you enjoy doing? Because all these things, like getting good grades is one thing, but when you start applying for jobs and you apply for schools, they're really going to be, like, so a lot of people have all A's, right? They're going to really look at who are you as a person? Like, can you work with other people? Like, are you a team member? How do you do well in stressful environments, right? Or what kind of experience do you have as a leader? So those are things that show that you're well-rounded, and those are really important things to take home. And so I think hobbies are super important. You know, what are your hobbies and interests? And I think hobbies develop your character, but they also give you confidence. So when you play on teams or you're in choir, and then suddenly you're in this technical field, like even for me, I would feel hesitant at first when I first moved down there. I always feel like I have something to say, but then I think if you join these teams and organizations or have activities, it builds your confidence to be able to speak up, which is really important for your voice to be heard. And you should always voice your opinion. And then just the take-home message. I like this message from Amelia Earhart. Who's heard of Amelia Earhart? she's definitely one of my idols, and she worked through a lot of challenges to get to where she was. And I love this quote because it's so true, and it's on my card. Never interrupt someone doing what you said couldn't be done. And I have definitely faced that, like the whole McMurdo deployment thing. There were people who were like, you can't do that, you can't do that, right? And I can just feel this rage building inside that you can't show on your face. That's the hard part. You're like, oh, that's not bothering me, but it is, right? So afterwards, anytime I run into something like that, I can't wait to succeed. And then this is the message I want to send them. Don't interrupt me doing what you said couldn't be done, right, after the fact. So, the message is to find your passions, like what keeps you driving through hard times, because there definitely will be hard times. Do what you love. Never say I can't. Never say I can't. If I didn't do well in something, I never thought I couldn't do it. I just got really angry, right? And then I tried it again in another way. Always follow through, and I think this is the biggest message. Like, you can be the smartest person in the world, and you invented this and that, but if you're not reliable, like, it's reliability and dependability that will get you, like, the hard jobs or the most exciting jobs. Like, if they know you can finish the task, not just say, I want to have it, and then always following through. I think, to me, that is a message. Always finish the task. Always do it. Super important. Don't be afraid to ask questions. Never be afraid to ask questions. And then at the bottom here, which you guys can just read, so some examples of STEM jobs in the aerospace sector, but STEM is embedded through all of society, and you can do anything you want with it, right? I just put some examples here with programming software. STEM you can design habitat systems like space stations on other planets, robotic systems, right? You could do that. Earth sciences, you can study the sun, astrophysics, the planets, life in the universe, right? You could be a coder, right? There's coding. We have people at Goddard they're all of our coders that program all the robotic arms that are going to fly in space someday and service satellite missions and stuff. Disaster responses, right? There's floods. So sometimes in airborne science, we'll get a call, hey, how quickly can you get an airplane out to location A and survey the flood damage, right? So there's really cool applications to studying STEM, like you're really contributing back to society or feeling good about what you do. And that is all I have.